Section 5.4, finding the derivative of e to the x. This, of course, is the inverse of the natural log of x. The derivative of e to the x is e to the x. Oh my gosh, it's that easy? It really is. Or you can think of it this way. If I have to take the derivative of e to the u, it's just going to be e to the u, then we have to derive whatever that exponent is. And normally it's just going to be an x, so if it's just an x, it'd just be a 1 there by the chain rule. But if it's something else, we have to multiply the derivative on the end. That's just the chain rule part right there. You can check this by using your lightsaber if you want to. Take the derivative of first graph e to the x, and then find the derivative when x is equal to 1. And you'll find that it is, in fact, e. Or when it is when x is equal to 2, and you'll find it's e squared. So that's an easy way to check this and verify that I am, in fact, not lying to you. Assuming, though, that I am telling the truth, let's go ahead and do these problems. First, y equals e to the 12x squared minus 4 over x. Find dy over dx. Well, the derivative of e to the x is just going to be e to the x, whatever that is. Then we have to multiply by the derivative of whatever that exponent is. So the derivative of 12x squared is 24x. This we can rewrite as 4x to the negative 1. So if I derive that, bring down the negative, that's going to make that positive 4x to the negative 2. There we go. That's it. For the next problem here, find all relative maximums or relative minimums, all relative extrema. Well, to find any relative extrema, I'm going to derive this. Y prime is equal to, well, I got to use the product rule here. So derivative of the first times the second plus the derivative of the second, derivative of e to the 4x is going to be e to the 4x. Chain rule, take the derivative of the 4x here, that's just going to be 4 times the first. The first function was x squared. So y prime here is going to be 2x e to the 4x plus 4x squared e to the 4x. Now, to find any maximums or minimums, what I have to do is I have to find when this is 0 or undefined. Well, when is this going to be 0? Well, this will never be undefined. When will this equal 0, though? This will equal 0. I'm actually going to factor this. E to the 4x, 2x plus 4x squared. So when is this going to equal 0? Well, e to the 4x never equals 0. We know that because the graph of it looks like this. It's a plane taking off. It never actually equals 0. It gets infinitely close, but never equals 0. So I can just rule that out. E to the 4x will never equal 0. So the question is, when is 2x plus 4x squared equal to 0? Well, let's factor that 2x first. Get 1 plus 2x. When does that equal 0? This is going to happen when x is equal to 0 and when x is equal to negative 1/2. So, find any maximums or minimums. The derivative here is really y prime is equal to e to the 4x times 2x times 1 plus 2x. I know this part right here is always going to be positive, so I just got to find out what's happening around 0 and negative 1/2. Now we can use our favorite method we can use the Belgian waffle method from our good friend Julie, who said as long as there's none of these are x squared or x to the fourths, Well, look what happens as it's going towards infinity, which is these are all going to be positive. So, and then we just alternate back and forth. So plus, minus, plus. Or we can actually check numbers in between. So for example, if I check negative 10, that's going to be positive. If I check negative 10 there, that's negative, that's negative. The two negatives make it positive. So that's in fact positive. So y prime is greater than 0. If I check a number between... Oh, I got those backwards, don't I? Negative 1/2 and 0. If I check a number between negative 1/2 and 0, like negative 1/4, that's going to be negative. That's going to be positive. So positive times a positive gives us a negative. So y prime is less than 0. And y prime, we already checked this one, is greater than 0 here. So because of this, we can say y has a relative maximum at x is equal to negative 1/2 because y prime changes from positive to negative. And I can say y has a relative minimum at x is equal to 0 because y prime changes from negative to positive. And of course, this is the justification we have to use for the AP exam. We don't just say because we have to be very specific. The function y has a relative maximum because y prime, not the derivative, not the slope. We say y prime changes from positive to negative. Our next problem here, the population of Greencastle can be modeled by P of t is equal to 9,880 e to the 0.031 t. T is the year 1990. When is the population of Greencastle changing by 40 people per year? Well, to find out how fast something's changing, we need to find the derivative. So let's find the derivative of this thing. P prime of t is going to be 9,880. If I derive this, it's e to the 0.031 t. Chain rule, derivative of that, is just going to be 0.031. And so I got to find out when is it changing by 40 people per year. Well, 40 people per year, that's the rate at which it's changing right here. So what we're really going to do here is take e to the 0.031 t. We're going to divide both sides by 9,880 and divide by 0.031. And I'm going to use my lightsaber here and figure out when that's going to happen. And I get this big nasty number of 0.13059945,148, and it keeps going. And to actually get my answer though, I'm going to have to get rid of this e, so I'm going to natural log both sides. when I take the natural log of that number, I'm going to get 0.031t is equal to negative 2.0356 2026. And once I divide that by 0.031, I get negative 65.6651697. I'll go ahead and round that last number. So when did that actually happen? That happened when t was negative 65. Well, if t is 0, then that's in 1990, so that means it's going to happen 1990 minus 65 point blah 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 blah. And I would get 1924.3348. But for all practical purposes, it's good enough to say 1924. All right. So that's how you find the derivative of e to the x. The next video will be about integrating e to the x. Thanks for watching.